Hello dear students, today I will discuss a simple problem on Galilean transformation. So the problem is two electrons are ejected in opposite directions from radioactive atoms from a sample of radioactive atom at rest in the laboratory. Each electron has a speed 0.67 c as measured by a laboratory observer. What is the speed of one electron as measured from the other according to the classical velocity addition theorem? So, the speed of each electrons are here measured with respect to an laboratory observer. So, at first, I will just simply draw our laboratory frame. So let's say it is our laboratory frame. So what we will do next? In laboratory frame, if the observer measures let's say this is the number 2 electron, this is the number 1 electron, ejected in opposite directions. So both of them has a velocity 0.67 c. That means this frame is at rest. So while laboratory frame is at rest, the velocity measured at like this. Now the question is, what will be the velocity or speed when measured from another electron? That means in the second case, what I have to do? I have to just put my observer here. So in my first case, the observer was here who is measuring both the speed of both electrons. In the second case, the observer is here. So obviously, since the observer is here, we have to consider a frame. We have to consider a frame attached to this electron. So you are taking the number 1 electron. So what I will calculate? We will calculate speed of number 2 electron with respect to an observer sitting on the number 1 electron. So we have to draw a frame of reference attached to the number 1 electron. Simply we will draw. So just draw. Sorry. So now when this observer is measuring the speed of this electron, we can solve the problem in many ways. What I will do? I will take this one as my S frame. This one is my S frame. So it is my X, this is my Y, and this is my Z. And the first observer was sitting. So what data we have? We have the data that the second electron, the speed of the second electron with respect to the laboratory frame is 0.67 c. So we will take the laboratory frame as S prime frame. X, Y, X prime, Y prime, Z prime. Now, what next? Previously, we have taken the laboratory frame at rest. But now, to solve further, we will take S prime frame as moving. So, how is that possible? Because we know that the number 1 electron is moving in opposite direction, means this is positive direction I can take, and this is negative direction. So this electron is moving. So how can I take this one as rest and this one as moving frame? Yes, we can take. That is the beauty of physics. How? So to take that, so we know that number 1 electron is moving in negative x direction with the speed of 0.67 c. Further, I will write, we assume number 1 electron as S frame and laboratory as S prime frame. So we know that the relative velocity between S and S prime is 0.67 c. We can just say S prime is moving in positive x direction with respect to S frame with the speed of 0.67 c. So initially what we had, that this observer was at rest and the electron 1 is moving in the negative x direction with a velocity of 0.67 c. So with respect to this observer, this electron is moving in this direction with 0.67 c. So the relative velocity between these two frames is 0.67 c. Now we will just reverse the situation. We will just reverse the, initially it was at rest, it was at motion. If we just reverse the situation, just reverse. So what we get? We will put this one at rest and we will put this S prime frame as moving. And now we can say that S prime frame is moving with velocity is of 0.67 c along positive direction with respect to S frame. So our second case is S frame at rest and S prime is moving with 0.67 c speed along x direction. So 0.67 c along x direction. What that means? That means velocity is equal to 0.67 c I cap, because velocity has both the magnitude and direction. So what we finally get? What is our scene? So our final scene is like this. So this is our number 1 electron. That is my S frame at rest. This is my laboratory, that is my S prime frame moving with a velocity of 0.67 c, and here is my number 2 electron, which is also moving with 0.67 c with respect to S prime, that means with respect to the laboratory observer. So as I have told you previously that if, so here my particle is the second electron S prime. If the velocity of a particle in S prime frame is u prime, the velocity of a particle in S frame is u, and the velocity of S prime frame with respect to S frame is v, then what? Then simply we can write that u prime is equal to u minus v. This is the velocity transformation equation. We have already derived this one. Now in our case we know all the things. We know u prime is equal to 0.67 c along x direction, v is equal to 0.67 c along x direction. So putting these values, let's say this is my equation 1. So putting these values in above equation, what we get? We get 0.67 c I cap is equal to u minus 0.67 c I cap, or u is equal to 0.67 plus 0.67 C I cap is equal to so what was U? U was the velocity of the particle in S frame. That was U. So here my particle means number 2 electron, and S frame means number 1 electron. So our final result is the velocity of number 2 electron with respect to number 1 electron is 1.34 C along positive x direction. So you can simply say the relative velocity of 1 electron with respect to not when we are saying relative speed, the relative speed or velocity, anything you can say, with respect to another electron is 1.34 C. Now here to mention C is speed of light. So you say in classical approach the speed of one particle can be greater than the speed of light. But what do we know? We know the speed of light is the maximum speed that anyone can achieve. So what's wrong? What's wrong here? That I will discuss in my next lecture.